Land reclamation has always been vital to the urban development of Hong Kong due to the ever-growing population and ensuing housing demand. With Hong Kong transforming into a smart, green, and resilient city, it is essential to steer our reclamation approach towards a more sustainable direction as well as giving due consideration to the environment.
We have developed an innovative technique for land reclamation by using local dredged Hong Kong marine deposits and waste as the fill materials, which is more economical and efficient to the current practice.
Under the current reclamation practice, 70% of the fill materials are from public fill, comprising rocks, concrete, rubbles, bricks, and competent soils, while the rest are sea sand and manufactured sand. The demand for sand resources far outpaces the natural supply, resulting in the rising cost of raw materials, not to mention the time costs in processing and shipping.
We have been searching for other competent fill materials that have great potential, one of them being dredged Hong Kong marine deposit, to replace traditional materials in a cost and time-effective and sustainable manner.
But dredged HKMD has never been used for land reclamation in Hong Kong before. Furthermore, dredged HKMD slurry has a high initial water content, low permeability, and negligible initial bearing capacity. This makes it unfavorable for construction. In order to make dredged HKMD a competent fill material, Professor Yin's team applied a combined ground improvement method with prefabricated horizontal and vertical drains, plus vacuum preloading and surcharge loading to speed up the consolidation of dredged HKMD slurry and existing deposits on the seabed together. Element tests and physical model tests were carried out in PolyU's laboratory on how to further strengthen dredged HKMD with two types of waste. One was incinerated sewage sludge ash, ISSA, generated from the burning of sewage sludge in Hong Kong. The other was ground granulated blast furnace slag, GGBS, generated from iron steel making industry in Chinese mainland. Results show that mixing lime with ISSA and GGBS amongst dredged HKMD could considerably reduce its water content. This in turn could enhance its stiffness and shear strength significantly. On the other hand, utilizing ISSA and GGBS for improving soft soils not only could reduce the cost of waste disposals, but it can also reduce carbon dioxide emissions. Most recently, a prototype field trial was conducted in a testing pit at the Dong Chung New Town Extension project using a 12-meter long, 8-meter wide, and 3.5-meter deep pit. Over a 7-month period, the trial succeeded in affirming the potential of dredged HKMD as a fill material and demonstrating the viability of this combined ground improvement technique under local field scale conditions.
With more scientific data from the field as evidence, it will enable us to convince approval bodies, practitioners, and the general public of the advantages of the new technique.
The positive outcome of the research provides a more economical, efficient, environmentally friendly, and sustainable land reclamation solution for Hong Kong. If widely adopted by the industry, this project will make a major achievement for sustainable urban development in Hong Kong and the Greater Bay Area.
By advancing the frontiers of knowledge and technology research, we together make our society, or even the world, a better place.